Next, we're going to look at ordered pairs. And so I want to draw your attention to the bottom of page 2, or in the box in page 2. And here I want to highlight just ordered pair. An ordered pair is the way in which we write a point on a graph, where it's always the input comes before the output. And one of the things to recognize in all of these is that this is alphabetical. So I comes before O. We also know that, and I'm just going to write it up here, we also have horizontal. So the horizontal axis comes before the vertical axis in terms of H comes before V. And then in the next lesson or two, we're going to talk about domain, which D comes before R for range. So these are several ways that we can associate our inputs and outputs, and we can always think about these in terms of how this is alphabetically. So back up the top, we're talking about this coordinate points, which are called ordered pairs, where again we have the input is first. So the input is first, I comes before O, so the input, then the output. So we want to talk about what these points represent or what they mean in terms of the problem. So what do they represent or what do they mean? So first we want to locate the point 1050. And so if we go back up to our graph, and so 10 means that we're talking about, so we're looking for the point 1050. So 10 is my input, so I go along the horizontal axis first. So I find 10 and then up to 50. And so I end up with this point right here. And that point is 10, comma, 50. Okay, so that's where it's plotted. And now we want to state its meaning. And again, the 10 is talking about the temperature, and the 50 is talking about the altitude. So we would say, and in these sentences, we always have to have an input part of the statement and an output part of the statement. So again, this is this idea of covariation when we're talking about two variables. So 10 is again our temperature. So at 10 degrees Celsius, so there's our input part of the statement. The altitude is 50 kilometers above Earth's surface. Indicating, again, an input part of our statement and an output part of the statement. For letter D, or I guess no, letter C, negative 20 and 37. So negative 20. So this time, for the negative 20, we're going to go to the left to negative 20. And then 37 is going to be our point right there. And so again, we went to the left 20, so that's negative 20. And then we went up to 37. And so this meaning is at 20 degrees Celsius below zero, the altitude is 37 kilometers above Earth's surface. Okay, so now let's talk specifically about quadrant. So our coordinate system, or our graph, is made up of 4 quadrants. We start with the upper right quadrant and go in counterclockwise order. And so the values in the first quadrant are positive, positive. So we go positive to the right and then up, which is also positive. Quadrant 2, we're going to go negative, because we're going to go to the left first, and then we're going to go up, which is still positive. For quadrant 3, we go negative, because we're going to go to the left. And this time we're going to go down, which is also negative. So this is the negative, negative quadrant. And then quadrant 4, we're going to go to the right. So this is positive. But we're going to go down, which makes this negative. So that's the positive, negative quadrant. So that helps us identify where points would be located. All right, so now let's look at this coordinate plane. And I'm just going to identify some of these points. So A has already been identified for us. F is over here. So we went negative 80, and then we went up. We have to figure out what this tick mark is. Well, it's halfway in between, so this must be 50. I'm sorry. All right, so we're looking at F here. So we have negative 80 because we're to the left, and then up, and it looks like up is halfway, so that's going to be 25. Let's look at, let's do G, and G is this one right over here. It sits on the vertical axis, and so G is 0 because we don't go left or right, and then it's down to negative 50. And then how about L? L is up along the horizontal, the vertical axis, excuse me, and then 250 is how high it gets. Let's see, how about I? I is to the right 40 and 150. And let's see about E. E is 50. So this time we went to the right 50, but we did not go up. So that's going to be 50, 0. And J is negative 20, 0. All right, so these points here, G and L, and I'm going to highlight them, G and L, are special points, and so are points E and J. Okay, so G and L, they lie right on the vertical axis, and so these are what we call the vertical intercept. These are points that lie on the vertical axis. And their ordered pairs are always 0, some value, some output. Just an unknown output. Whereas E and J are known as the horizontal intercept. These are the points that lie on the horizontal axis. And when they lie on the horizontal axis, that means that we have some unknown input, so some input, comma, the output is always 0. One else thing to take notice in terms of the vertical intercept and the horizontal intercept is this noted here. The vertical intercept is the coordinates that cross the vertical axes. So the input is always 0. So again, this looks like 0, comma something. And the key thing here, we're going to remember some words from the previous class, or just to know this is evaluate. And for our horizontal intercept, that means we have something. We don't know what our input is. And 0. And we also think of this in terms of solving. I want to just highlight something here in terms of where it says that you want to spread the data across the entire grid. So if you notice here that the height does not start at 0, and there's only numbers between 58 and 74. And so rather than starting, so we don't want to start, so this point here, let me just reiterate, this point here is always 0, 0. That's the origin. We can't ever change that point. But we don't have to count starting with 1 or 2 and skip. We can count starting with, say, 50 or 55 and go from there. If we count, say, starting with 55, then what we want to do is put 2 little slashes that indicates there's a break in the graph, because then the next number I put here, let's say I put 56, then I know that we're counting by 1. Each tick mark is a count of 1. Same thing we can do along the horizontal or the vertical axes as well, keeping in mind that now we're going from 115 to 186. So again, 0, 0. But we can start with 115. That's fine as well if we want to, or we can start with 110. Again, we want to put a break in the graph, and whatever number I put next is telling me what the tick mark's value is. Whatever that next number that I put here. So if it's 120, then that means I'm counting by 5s. If it's 116, then I'm counting by 1s. Regardless, your horizontal and vertical axes, you can count by different amounts, just like we saw on page 1.